Hello, this is Dr. K. Welcome to Module 12 on software testing. This module is based in part on chapters 22 and 23 of Software Engineering, a Practitioner's Approach by Roger Pressman and Bruce Maxim. In this video, we're going to talk about software testing strategies. This definition of software testing is right out of Pressman. Testing is the process of exercising a program with the specific intent, and that's important, the specific intent of finding errors prior to delivery to the end user. These are the topics that we're going to cover in this video. Who should do testing, the developer or an independent tester? What is validation? What is verification? And what's the difference between them? What are the different kinds of tests we can run? And finally, what is system testing? And what are the different kinds of system tests that we can run? Let's look at the first item first. Who should do the testing? There are two possible answers to this question: the developer or an independent tester. And perhaps more importantly, what are the benefits and drawbacks of each approach? Before I give you Pressman's answer, please pause the video and figure out how you would answer this question. As the question suggests, there are benefits and drawbacks to each of these options. Let's take a look at them. The benefit of the developer testing the system is that the developer understands what the system is supposed to do. The big drawback of the developer testing the system is that the developer does not have the mindset to try and break the system. In fact, it's just the opposite. Developers tend to test their systems lightly, with sunny day scenarios, those that occur most often. However, a good tester will try to break the system. A good tester knows that bugs tend to occur in the boundary cases, the cases that do not necessarily occur that often, but are critical to the software working correctly. The drawback, of course, is that an independent tester has to get up to speed on the system under test. You might think, because of what was just said, that an independent tester should always be the one who tests the system. In fact, it's a pretty good idea if both the developer and the independent tester test the system. Certainly, in test-driven development, it's the developer who's writing the test. Even in situations where you're not doing test-driven development, developers should still be writing unit tests for their code. Okay, that's the first item we wanted to address regarding testing. The second thing we want to address is verification and validation. What are they, and what's the distinction between them? Please pause the video again and attempt to answer this question before we discuss it. Okay, verification and validation are often used in the same phrase. You often hear of V and V, but they are different. Now let's see how. A quick way of distinguishing between verification and validation is by saying that verification tells you if you are building the product right, meaning are you building the product correctly? And validation tells you if you're building the right product, meaning are you building what your customers want you to build? In verification, you already have some kind of specification or model, and you're trying to write your code in such a way that it's consistent with that model. In validation, you're trying to create the specification or model. You're trying to interpret the requirements that you have been given and formalize them and make them consistent. Both of these are challenging tasks for the software developer. But of the two, most software engineers would probably say that validation is the more challenging task. That's because it involves human intentions, which can often be hazy, ambiguous, and even variable. They can actually change from one day to the next. Unit tests are a form of verification. You know what your component should do, and you write your test to make sure that it does it. Acceptance tests are a form of validation. These tests involve the customer using some portion of the system to see if it works as they intended it to. When testing a particular system, you start with unit tests and work your way up to system tests. Unit tests are closest to the code. These test the modules or components of your system. In object-oriented programming, unit tests are typically written for a specific class. Integration testing ensures that the components work well with each other. Validation testing are acceptance tests, and they involve the customer. System testing takes many forms, but they all test the system as a whole. Unit testing tests individual components, and integration testing tests how components interact with one another. A special category of integration testing is regression testing. We've gone over this before in a previous module, so I'm hoping you remember what regression testing is. If you're not sure, or if you kind of remember but it needs a minute to bubble up to the surface, please pause the video and think about how you would tell someone what the purpose of regression testing is. Ready? The purpose of regression testing is to ensure that you don't break things that had previously worked when you're trying to modify the system. So, regression testing is a kind of retesting. You run a suite of tests periodically on the entire system to ensure that nothing gets broken as the system evolves. Periodically usually means several things. There's usually a set of tests that developers are asked to run before they are allowed to check new code into the main repository. There may be a more comprehensive suite of regression tests that is run daily, often at night when the system's not being modified as much. Every place you work will have their own conventions. In Pressman's words, regression testing is the selective retesting of a modified system to help ensure that no bugs have been introduced during modification. In validation testing, the focus is on software requirements. Acceptance testing is a kind of validation testing. The customers, and possibly other stakeholders, are typically involved in this process. In system testing, the focus is on system integration. Remember, the system involves much more than just the software. It involves the software and the environment in which it's intended to run. Listed here are a few kinds of system tests. Please take a moment to pause the video and see how many of these you know. Ready? Let's see what Pressman has to say about each of these tests. You've probably all heard about beta testing before. Software that is still in beta is typically released to a subset of users, so a company can get feedback from them about problems with the software. Alpha testing is a similar thing, but the software is in even less of a finished state. Recovery testing is when you force the software to fail, so that you can make sure that the software gracefully recovers from the failure. Security testing tries to ensure that the software is not subject to hacks or various forms of attack. In stress testing, you put high demands on the software with regard to system resources and make sure that the software can still perform. Finally, performance testing tests the runtime performance of that software. And that's it for software testing strategies. In the next video, we'll talk about black box testing and white box testing.